Right, hiya guys. In today's lesson here, I know we're talking about surds. I know that's the topic, but I've got a laptop, so I'm going to show you something different to do with surds. And what you need is a pencil, yes, a ruler, sounds, and a protractor. And I know protractor, you might not necessarily have one, but like I know that these protractors in the shop at the top of our road, so I don't reckon they're that hard to get. But if you really can't get one, then the only reason you need a protractor is to draw 90-degree angles. So you can sort of get on with that without one really if you have to. But right, anyway, right. So more important than that, what do you need? You need Pythagoras' theorem, because we're going to draw the loads of right angled triangles and work out the hypotenuses. That's what we're doing. So say we had a right angled triangle what looked like this, yeah? Right, so we'll draw this in a minute. 1 centimetre, 1 centimetre, and then x. So let's do Pythagoras' theorem on that, okay? X squared equals 1 squared plus 1 squared, not hard, this is it, yes. So x squared equals 1 plus 1 is 2. Right, so then x is the square root of 2. Now, I think that's boss, because, you know, you guys have been learning about surds, and the point about the surds is let me get your calculator out here. Yes. Right. Root 2, go ahead. Equal, well, yeah. Alright, change it. It's a number that you can't even write down. The whole point of surds is they go on forever, they don't repeat, you can't write them down. And yeah, we can draw them. So there's, I'll draw it accurately in a minute, like, but there's a number that we can't write down, but that we can actually draw, and that's what I want us to do. Okay, so we'll start this off, it'll be a little bit awkward, this, but let's see how it goes. So I'm going to draw, because it's small, it's a bit awkward to be honest, but I'm going to draw 1 centimetre along, and then I'm just going to, it's not boss this because it is small, and the whole way along, I wish it was bigger to be honest, but it isn't. I'm going to draw 90 degrees now. Okay, and this is as I say, this is all you need your protractor for, just draw at 90 degrees. Okay, there we go. I want to be accurate though. Okay, and then I want to draw 1 centimetre up. Okay, so I'm going to go, there we go. I'm going to go from 17 up to 16. Okay, right, and then if I draw that, that'll be root 2, and that's the point now. That's not all I'm asking you to do, like, but that's the start of it. So there's our triangle that we talked about before. 1 centimetre, 1 centimetre, root 2. Now, what happens then if we draw another right angled triangle? So I'm going to draw it so that's one length, and then I'm going to draw 1 centimetre on there. Well, let's work it out. Here's our piece of paper, we're working it out. So what did I say? We'll draw that one, like, so there's that length there, and there's 1 centimetre, another right angled triangle. So that's root 2, and that's 1. I want to draw that there. Not draw, well, draw it, yeah, but work it out. So let's do Pythagoras' theorem again. X squared equals root 2, put that in brackets, squared plus 1 squared. What's root 2 squared? Root 2 squared is, the whole point of it is 2. So I've got 2 plus 1. 2 plus 1 is 3, nice one, okay. So x squared is 3. So x is the square root of 3. So I've drawn a line that's the square root of 3. So what I'm going to do is I'm going to draw it on here. Okay, so there's me original root 2. I'm going to draw 90 degrees from this point here. Right, again, trying to be as accurate as I can. And I'm conscious that it is a bit of a nuisance this because everything's a bit small, but that's the way it goes. Right, I'm going from 12 to 11 when I do it. Right, there's 12 there, going to 11. Yep. Nice one. Okay, and then when I draw that, the point is that is root 3. Nice one. Okay, and then I go again. Let's do it again. And we keep going round then, and it's nice this, but just work out this last one on Pythagoras. So that one was a bit sort of up, wasn't it? Let's draw that. That's root 3. And then we're going to draw 1 centimetre at right angle, and then work out what that is. And you should start to see the pattern. Okay, so let's work this out with Pythagoras' theorem. Call this x again. X squared equals 1 squared plus root 3 squared. I put that in brackets again. So x squared equals 1 plus, again, do you know what root 3 squared is? Root 3 squared is 3. Nice one. So x squared equals 4. So x equals the square root of 4. Yeah, but we know that, don't we? You can actually work that one out. It's 2. Okay, so there we go, and we'll carry on, and let's do this then. Okay, and this is the pattern of what we're doing. Okay, so here we go. 90 degrees from the end there. There we go. Okay, and I'm going to measure that. It does get a bit awkward as we're turning it round, but going from 14 to 13 there. You just have to try and do your best to try and make sure that each of these are 1 centimetre. Okay. And you just keep going round, okay? And you should see the pattern, as I say. It's a bit fiddly, but it does come good. And then, right, I've done quite a few when I did my one before. Here's my one that I did. I'll just show you. Right, I went round and I did about, well, I know how many I did 16 triangles, like, and that's quite a good number. But what you can do is, there's mine, and you can see, I'm not sure if you can see, because it might be a bit faint, but I've got all these little marks here where I measured 90 degrees. What's nice is, I like anyway, these seem to get closer together. I like that. It's interesting, that. But you could label this as root 2. If you're nice and careful, like root 3, and then we worked that out was 2, didn't we? And you can carry on and see if you can see the pattern all the way around. And as I say, well, no, I haven't said, like, but as I'm saying now, some of these, like this one, are actually not surds. Some of them are whole numbers or rational numbers, but you end up with a nice picture like that. And really, that's what I think is a good thing to do. It takes a bit of time, but it is good. And if you can draw a picture like that, and then label the hypotenuses with the relevant surds, you should see the pattern. And then if you send a picture of that to me, well, that's a boss piece of work that you've done there. So good luck doing that, and see how you get on. Nice one.